The last topic in this chapter is the Doppler effect. Okay, what is the Doppler effect, right? So if we have the source moving in one direction, okay, it means that the frequency of the sound wave detected by the listener is going to be different than from the frequency that the source emits out. Okay, so that's called the Doppler effect. So this phenomena can see by this. Okay, so this one just from the Wikipedia. So you can see that, okay, if the source, right, just stay at rest, it means that it will radiate the electromagnetic wave, the sound wave in all directions uniformly. But then in this case, if the source is moving to the right hand side, okay, and then if the listener is on the right hand side of the source, so it means that the wavelength of the sound wave that the listener can detect, right, is going to be smaller than this case. Okay, it's going to be smaller than this case. So here it means that the frequency that the listener can detect, right, is going to be higher than the frequency that the source emits. Okay, but now on the other hand, if if the listener is on the right, the left hand side of the point source, so you can see that the wavelength that the listener can detect, right, is going to be the larger than the normal wavelength here. On the other hand, the frequency that the listener can detect, right, is going to be lower than the frequency that the point source emits. Okay, so that's called the Doppler effect. Actually, in this case, right, it's not only limited to the point source moving, but it can be limited to, the listener moving to or just out from the point source as well. Okay, so look at these equations. So let's say that if we have the source, okay, with the velocity equal to the Vs here, so now the S just stands for the source, and we have the listener moving with the velocity equal to the VL. The L here just stands for the listener, right? And then if we have the V to be the speed of the sound wave in the air, okay, because the atmosphere here just the air, right? And then the Fs is the frequency of the sound that the source emits. So the S just stands for the source, as I just mentioned before, right? And now the FL is the frequency of the sound detected by the listeners. Okay, so the L here just stands for the listener. Then we can have the relationship between the FL and the Fs by these equations. Okay, so just remember this equation. FL is the frequency that the listener can detect, right? And the Fs is the frequency that the source emits. Okay, and we have the V here, the speed of the sound wave in the air. The VL and the Vs are the speeds of the listener and the source respectively. But now the problem is the sign, the plus and the sign. Okay, so which one should we use, the plus or the minus, right? It just depends on the situation. Okay, for example, let's consider this. If let's say that if the listener just stay at rest, okay, if the listener just stay at rest, so 0 meter per second. But now if the source is moving away from the listener, okay, if the source here is just moving away from the listener with the velocity equal to the Vs, right, as we just mentioned. Okay, from the real life, we know that if the source, for example, the ambulance or the police car, right, it's just moving away from the listener, we're gonna hear the sound with the lower frequency, right? We're gonna hear the sound with the lower frequency. or we can just look at this graph, right? Okay, so you can see that if the listener is here, but now if the source is just moving away from the listener, so it means that the wavelength that we can detect is going to be the larger, or the frequency should be lower. Okay, then in this case, okay, we need to pick the sign in front of the Vs here. So which one should we use? Okay, we say that if we want to have the FL smaller than the Fs, okay, in this case the FL must be less than the Fs, right? Because the frequency that we can hear should be lower than the frequency of the source. If we need the FL to be less than the Fs, it means that we need to pick up the plus sign here. Why? Because if we pick the plus sign, right, we're gonna have the V plus the Fs. So it means that this denominator should be larger. Then when we divide it, so the FL should be smaller, and that's it. Okay. Then we're gonna pick the plus sign. We're gonna pick the V and then plus the Vs. Okay, the Vs just for the source here. Good. Okay, so let's look at another case. In this case, oops, sorry. In this case, if the source, for example, the ambulance or the police car, right, just moving towards the listener. So from real life, right, we can say that the FL should be larger than the Fs, right? It means that we can hear the frequency which is greater than the frequency that the source emits. Okay, for example, if we look at this graph, right, so if the listener is at this position, okay, and you can see that the source is just moving towards, the listener. Okay, so we're gonna hear the frequency, right, should be larger because the wavelength is smaller. Then in this case, which side should we pick, right? We need to have the FL greater than the Fs. In this case, we need to pick the negative side. Because we have the V minus the Fs, it means that this denominator should be smaller. When we divide it here, FL should be larger. Okay, so we're gonna have the V and then minus the Vs here. Okay, so now in another case, okay, so here they say that if the source is at rest, okay, for example, if the ambulance or the police car is at rest, but now if the listener is just moving towards, okay, to the source. Okay, so if we just running the car or if we just driving the bicycle towards the source here. So what do you think about the frequency? If we just want to compare between the FL and the Fs, right, which one should be larger? Okay, so let's think first from the real life. If we driving a car towards to the ambulance, right, so you can see that the FL should be larger than the Fs. Okay, the FL should be larger than the Fs, right? It means that the frequency that we can hear should be larger than the frequency that the source emitted out. In this case, okay, so let's look at here. We need to pick the sign that the FL is greater than the Fs. Okay, so which one is that? It must be positive sign, right? Why? Because if we pick up the positive sign, it means that this numerator should be larger. Okay, so that's why the FL should be greater than the Fs. Then in this case, okay, we're gonna have the V, right, and then plus the VL. Okay, so now for the final case, if the listener is just moving away from the source, okay, if the listener is just moving away from the source, So as you can see, the FL should be less than the FS. Okay, the FL should be less than the FS. So if we need the FL to be less than the FS, it means that we need to pick the minus sign, right? Because if we pick the minus sign here, so this numerator should be smaller and it's going to have the FL less than the FS. Okay, we're going to have to pick the minus sign here, and that's it. So that's going to be the sign convention that we can use, to solve for the perfect, right? But I would recommend that you don't need to remember this diagram, okay? Because if you understand about, okay, the FL larger or the smaller, and you can just pick the sign using the mathematics, and that's it. Okay, so let's look at these examples. The submarine A, right, travels through the water at the speed dx meter per second. So let me just draw the picture first. We have the submarine A. Let me just draw it as the rectangle. And okay, maybe just flip the color. Yep. So this will be the submarine A. Okay. So it's just moving through the water, right, with the speed equal to the x meter per second, and then emitting a sonar wave at the frequency equal to the 1400 hertz. Okay, so let's say that the A, right, is just moving to the right hand side with the velocity equal to the x meter per second, and then it's going to emit the frequency the 1400 hertz. Okay, so let's say that this is going to be the source, right? This is the source. So let's say that the Fs equal to the 1400 hertz, and then this will be the Vs of the source. Okay, now we have the submarine B, right, is located such that both submarines are traveling directly towards one another. So we're gonna have the submarine B. Oops. Okay, we're gonna have the submarine B here. Let me just. Okay, let me just change the color to be. Yeah, this one. Okay, so the submarine B is moving towards the submarine A with the speed equal to the 9 meter per second. Okay, and the speed of the sound in the water equal to this one, right? So we have the V, the speed of the medium, right, equal to the 1533 meter per second. So now for the part A, what frequency is detected by the person in the submarine B? So it means that this submarine B, right, is going to be the listener. Okay, so we're going to have the VL here equal to this one. Okay, this is for the part A. Okay, so now let's do the equation. Okay, so we said that the FL equal to, okay, let's just write down first. We're gonna have the V and the VL, right? And then the V and the VS, and then times the FS. Okay, so I just haven't, write down the sign here. But now let's just consider the sign. Okay, in this case, you can see that, both of them just, moving, toward to each other, right? So now, okay, if the source moving towards the listener, so it means that the FL should be larger, right? Because if the source moving towards the listener, so we should hear the frequency larger than the source. Okay, so now, okay, let's consider this. If we just want to have the FL greater, it means that we need to pick the negative sign. Okay, we need to pick the negative sign here, and that's it. Okay, so now just come to the listener. This listener is just moving towards the source as well. So it means that the listener should hear the frequency larger than the source. Okay, so in this case, it means that we just want to get the FL larger than the FS, right? Then we need to pick the plus sign. Okay, so now we just plug everything into the equations. Equal to 1533, right? Yep. And then plus the VL, it's just the 9.00 meter per second, and then over the 1533, and then minus the VS, right? Just the 8.00, and then times the FS 1400. Then in this case, it's gonna be equal to the 1416 hertz. Okay, that's gonna be the answers. So you can see that the frequency that the listener can hear, right, is going to be larger than the frequency of the source. Now for the part B. On the other hand, the submarines barely miss each other and then pass. So what frequency is detected by the submarine B as both submarines desist from each other? So then in this case, it means that both of them will just moving away from each other, right? So I'm gonna have the picture something like this. Okay, so both of them just gonna move away from each other. So now we just want to find the FL. Okay, so we're gonna just use the same equation here. We're gonna have to use the same equation here. Okay, so now for the sign, right? Because the source is moving away from the listener, it means that the frequency that we can hear, right, should be lower than the frequency of the source. Then for the source here, we need to pick the plus sign, because if the denominator increase, right, so the FL should be decreased. Okay, and then okay, so now the listener is just moving away from the source as well. So it means that the frequency that we can hear should be lower than the frequency of the source. So we need to pick the negative sign, because this is the numerator. If the numerator decrease, so it means that the FL should be decreased, right? Then we just plug in the number. The same thing. Okay, and then times the 1400, right? And then finally we can get number to be the 1385 hertz. Okay, so you can see that the frequency that the listener here, right, it's just less than the frequency of the source. Okay, so that is the end of this. This is the end of this chapter.